Okay, the next worksheet that I have posted for you for your ACT review material is area of circles. So we just want to refresh our memory on a few things that we've talked about with circles. First of all, I have a diagram showing us what the radius of a circle is. We've talked about the diameter. The diameter is the same thing as twice the radius. So if I'm given the diameter to find the radius, I would divide by 2. A chord means that you have a line segment where the two endpoints are on the circumference of a circle. A special type of chord is the diameter. We have a secant, which is a line segment that cuts through the circle. The endpoints aren't on the circumference of the circle. And then you have a tangent, and just for easy definition of a tangent for right now, which I can get more specific because in calculus we don't like this definition, but it touches the circle in one point, and that's what a tangent is, which you can get questions on your ACT that says this segment or this line is a tangent to circle Q at point C. It just means it touches the circle at point C. Formulas you would need to know. We have a formula for circumference of a circle. Put your finger on the jar. Circumference is 2 pi r. So circumference is the same thing as 2 times pi times the radius. If you multiply 2 times the radius, you're going to find out that that means the same thing as pi times the diameter. Either way will get you the circumference of the circle. Area, as far as area of a circle is concerned, that's going to be, the formula would be pi r squared. So for the worksheet, I think you have about 10 problems. I think that's all there is. There's 10 problems, and it's just going to deal with finding the area of a circle. Within that, some of the problems may give you the equation of a circle and ask you to find the area of the region enclosed by that circle. So when you look at an equation for a circle, what we need to remember, the general equation for a circle is x minus h, that quantity being squared, plus the quantity y minus k squared is equal to r squared. So in that formula, what you are going to notice is that the center of the circle is actually the coordinate hk. And then r is going to stand for the radius. So for an example, if I told you I had the quantity x minus 2 squared plus the quantity y plus 4 squared is equal to 16, and if I asked you what is the area enclosed by the circle expressed in square coordinate units, well, the problem with this one is that they don't just plain flat out tell you that the radius is 3, so you can just go 3 squared is 9 and you get an answer of 9 pi. So what you have to remember, it's irrelevant for this problem as far as you don't need it for any calculation purposes, but we can talk about what the center is. Now the center, notice in the general formula you have minus h. So this is minus h, and right here is your h value, which is 2, so the x coordinate of the center of your circle is 2. But then it says y minus k, and in order to get y minus my k value, I would have to change this format to y minus negative 4. And then when you calculate that, y minus negative 4 means plus 4. So the y value is actually negative 4. So when you look at these, if you see this, if you just look at this and say it's negative 2, the center is going, the x coordinate of the center of your circle is going to be the opposite of that. So look at that as negative 2 and then say it's the opposite. This is positive 4, so the center is the opposite. Now, like I said, that's irrelevant for the worksheet that you're going to be working on, but we'll revisit it again maybe later when I give you another worksheet that deals with this general equation for a circle. The only thing I am concerned with for this particular problem, what is the area enclosed by the circle, is realizing something about this value right here on the right-hand side of the equal sign. That 16 is the same thing as the radius squared. Now, to get rid of a square, you do not divide by 2. That's incorrect. To get rid of a square, you take the square root, because a square and a square root are inverse operations of each other. So that means that your radius is going to be equal to 4. So what is the area enclosed by the circle? The radius is going to be 4. So the area of a circle is equal to pi r squared. So you have pi times 4 squared, and 4 squared is 16. So your answer is 16 pi. That's the area of the circle. And you would have square units. If I gave you units, say it was in inches, then it would be square inches. But I don't think anything on the ACT test is going to ask you for units. They're just going to give you something like 16 pi. So if you looked at the worksheets, if you have not looked at them yet, make note at 6 minutes, I have finished, so somewhere between 5 and 6 minutes on this particular recording. Problem number 4 has been answered for you on your homework assignment. Now, problem number 5 follows this same technique as what I have right here, and you can go ahead and calculate the answer for that one. Okay, so I went ahead and labeled that first example. I labeled it as example 1, and as I had mentioned earlier, that does happen to be problem number 4 on your area of circles worksheet. So just go ahead and find 16 pi and correspond that with the correct letter choice to answer that particular problem. So example 2 that I have is going to take this type of problem. It says a certain circle has an area of 9 square inches. How many inches long is its radius? So this one you are actually working backwards as far as solving. So given the area, so we know this. Write down what you know. Area is equal to pi r squared. So we know that the area happens to be 9 pi, and that's equal to pi r squared. So in order to solve this, because that's all you're doing, you've just set the area value equal to the equation for area. So we're going to divide both sides by pi. So if I divide both sides by pi, the pi cancels out, and you get 9 is equal to r squared. Now once again, that does not mean that you divide by 2. You have to take the square root. So if I take the square root of both sides, I get 3 is equal to r. So the radius of that particular circle, which is what they are looking for, happens to be 3. In this case, I could put the units 3 inches. But if you look at number 6 on your area of circles worksheet, this is the same problem as problem number 6 on your area of circles worksheet. And for this one, and all the others on here, you're noticing that they are not giving you units. So your answer is just 3. So for problem number 6, you can just go ahead and find out what letter choice corresponds with the 3, and that's your answer. Okay, here's another problem just like the previous example that I had worked through. A certain circle has an area of 9/25 pi, and I just wanted to refresh your memory on how to deal with fractions when you're solving through the equation. So we know that the area is equal to 9/25 pi. So the area of a circle is pi r squared, and that's equal to 9/25 pi. So the first step I'm going to do is I'm going to divide both sides by pi, which gets rid of it, and you are left with, from there, we are left with r squared is equal to 9/25. Now, I've talked about how you solve this is you take the square root of both sides. When you take the square root, you really get plus or minus values. But the plus or minus values, we don't have a negative radius. So we ignore the negative for this particular problem because it's irrelevant for this particular problem. But when you take the square root of a fraction, you take the square root of the numerator over the square root of the denominator, and that's what I wanted to point out to you. And the square root of 9 is 3, and the square root of 25 is 5. So you would end up with 3/5 happens to be the radius. Now, if you want to refer back to this for any particular problems in your homework assignment, it is around 8 and 9 in the video. Okay, I have 5 more minutes. I'm going to try to make this quick. I got 2 more examples. One of them is when you have a square inscribed in a circle. So your square is inscribed, meaning it is inside of the circle. They tell you that the area of the square is 2, and they want to know what is the area of a circle. So in order to solve this problem, I'm going to go ahead and sketch in the diagonals of my square for a second. And when you sketch that in, these are going, since this is a square, I don't have it drawn very well. That is not a square, so it does not look perpendicular here. But when you sketch in those diagonals of a square, that means that you're going to get a 90-degree angle right there. They tell you that the area of a square is 2. So you have to remember just a little bit about triangles in order to find this in the Pythagorean theorem. So if the area of a square is the side length squared, that's equal to 2, then the side length, which I'm letting be x is going to be equal to the square root of 2. So now what you have is you have this right triangle right here, where I know that this is the square root of 2. And I know that both of these values happen to be the same length because they are both, this crosses at the center of the circle. So both of these side lengths are radii of your circle, and that's why we need to find that. So r plus r, well, doing Pythagorean theorem, we're going to have r squared plus r squared is equal to the square root of 2 squared. So r squared plus r squared, those are like terms. So 2r squared is equal to the square root of 2 squared is just 2. So I'm going to divide by 2. And that means that your radius squared is equal to 1. And if you take the square root, your radius is 1. So the area of your circle, which you are looking for, is pi times the radius squared. So the area of the circle is just pi, square units. Okay, so now we've switched it up just a little bit. We had a square inscribed in a circle, so the square is inside the circle. And now we have a circle is inscribed, or the circle is inside of the square. They tell you again that the area of the square is 2. So we calculated that before. Area is the same thing as the side length squared, because the sides are going to be the same. So x times x is x squared. X squared is equal to 2. So I take the square root, and the side length of my square happens to be radical 2. So I know that this has a length of radical 2, and I'm going to just go ahead and mark that here on the sides. And if you look at the diameter of it, because what they want to know is what is the area of the circle. So I got to figure out what is the radius, because area of a circle is going to be pi r squared. So to find that, I know it's half of the diameter, and radical 2 is the same thing. The side length of the square is the same thing as the diameter of the circle. So the side length, or what I know here, is that the diameter is equal to radical 2. And I know that the diameter is twice the radius, so my radius has a value of radical 2 over 2. So I put that into my formula because I want to figure out what is the area of my circle. So it's going to be pi times radical 2 over 2 squared. When you square a radical, or not a radical, when you square a fraction, you're going to take the square root of radical 2 times itself, or square that, and then you're going to take the denominator, and you're going to square that. So radical 2 times radical 2 is just 2. So this simplifies into pi times 2 over, and 2 squared is 4, so I'm going to square the numerator, square the denominator. You get 2/4 pi, which reduces down to 1/2 pi. And that is the area of your circle. Some of you might just type that in on your calculator. Okay, so this concludes the area of circles, and it should help you with your worksheet.